In this video, we will be demonstrating the bending stresses in a beam experiment, the STS5, for the study of stress distribution across the section of a beam. This is one of the 21 different experiments within the next generation structures range from TecQuipment. Engineers need to be able to predict how a beam will behave in the structure they've designed so they can be confident that it will do its job. To check the behaviour of a structural element at key positions, engineers fit sensors at those positions. Using this practical hands-on experiment, students can learn about the stress and strain relationship, how the beam across section dimensions affect the second moment of area, understand how to use strain gauges in instruments, and methods of finding the neutral axis. Let's take a closer look around the experiment. The aluminium inverted T-section beam represents a common structural element. In some structures, you'll find an inverted T-beam used in a floor where the floor panels sit on top. The dimensions of the beam are displayed in the user guide, but there are likely to be slight variations due to manufacturing tolerances, which is why a vernier caliper is included, so that you can measure the actual dimensions for your calculations. The beam is held onto the structure's platform that is supplied separately by two supports. In the middle of the beam are 9 strain gauges fixed at different heights to measure the strains caused by the different loads applied. These are connected to a strain gauge amplifier. There is a lot of theory to explain how strain gauges work, including concepts such as the Wheatstone bridge, quarter bridge connections, Young's modulus, second moment of area, I-value, and neutral axis contained within the user guide. The load cell here measures the force applied at the mid-span of the beam. This is connected to the USB interface hub on the structure's platform, allowing you to connect to a computer for data display and data acquisition. Which then brings me on to the loading mechanism, which is hand-operated to apply a downward force on the beam. The experiment takes you through applying loads at 100 Newton increments up to 500, recording the strain readings at each increase in load. Now you're ready to chart the strain against the load and add the results of each strain gauge, either manually or within the VDAS software. Then comes the analysis. A more detailed video is available to show how to set up and the procedure to follow for the experiment. That wraps it up for today's video on the bending stresses in a beam experiment. You can find a link for more information, including the datasheet below. For general information about the next generation structures range, click on the links provided. For all the latest TecQuipment videos and live streamed events, make sure you follow the TecQuipment YouTube channel. Thanks for watching.